Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for almost a decade, and I've achieved a 99th percentile score on the GMAT and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS think our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 26. Doing real GMAT problems is one of the best ways to make test day go smoothly for you, so let's talk through a few examples together. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going to be talking through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to talk through together. The official guide contains retired problems that have appeared on past GMAT exams, and so these are going to be very similar to the questions you'll see on your official GMAT. I'll give you a chance to work through the solution on your own if you'd like to, and then I'll discuss my thoughts on what to take away from each one. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but do your best. It's a great way to challenge yourself. If you are in a situation where you can physically write down what you would on test day, like on a plane or a train, for example, I highly recommend that. Here we go. As we start to get into more difficult problems, we may occasionally sprinkle in an easier one to start as like a warm-up, so that's what I'm going to do today. If you have any feedback or requests about that, you can reach us anytime at the GMAT Strategy on current social channels, or you can email us at contact@thegmatstrategy.com. That's CONTACT at thegmatstrategy.com. This is problem number 96. We've basically got a bunch of fractions in this problem. The problem says 1 over 2 plus, in parentheses, 2 over 3 times 3 over 8, close parentheses, that whole 2 over 3 times 3 over 8 divided by 4, minus 9 over 16. I'll read that again. So it's 1/2 plus a big fraction, where on the top of this big fraction, you've got two fractions. So in the numerator of this big fraction, it's 2 over 3 times 3 over 8. And then in the bottom of that big fraction, it's just 4. And then the third term is minus 9 over 16. So we've got three terms. 1/2 is the first term. 2/3 times 3/8, that whole thing divided by 4 is the second term. Minus 9 over 16 is the third term. Option A is 29 over 16. Option B is 19 over 16. Option C is 15 over 16. Option D is 9 over 13. And option E is 0. I recommend pausing to give yourself an opportunity to solve this one. I'm just going to jump into my thoughts to avoid having a huge break in the action there. So obviously, we're really heavy on the fraction math on this particular question. I thought this would actually have a really high success rate since a lot of folks are pretty good with basic math, but actually only 83% of us are getting this question right. So let's dig into what might be happening here and just make sure you're rock solid on these kinds of questions. First of all, let's talk through a correct solution. In general, it's a good idea to simplify fractions by canceling whenever possible. So let's begin with that move, since I think most of us would agree that dealing with a simple fraction is preferable to dealing with a complicated fraction. You can see we've got two fractions being multiplied in the middle term there, 2 over 3 times 3 over 8. And we've got 3 in the numerator of one fraction and a 3 in the denominator of the other fraction. So that's a great time to do some canceling. If we do that, we get 2 over 1 times 1 over 8, and we can then multiply straight across and reduce to get 1 over 4. If you're not so brushed up on your fraction math, like this is your first contact with the exam or you're just trying to get the ball rolling here, we've got a whole math basics episode linked below on fractions that will walk you through like upskilling or reskilling on fractions, because it might have been a while since you thought about how to do fraction math without a calculator. And there's no calculator on the GMAT quant section. You do get a calculator on data insights, but not on quant. So this hand computation, it's usually something most of us have to brush up on a good amount when we're getting into the groove with GMAT prep. I was in the same boat when I started, and it took a while, but I got there eventually, and I'm sure you can too, especially with our Math Basics series, which should help you greatly accelerate your progress there. So that's there if you want it. So we combined the top two fractions of the middle term to get 1 over 4. That's good news because that's much simpler than where we began. And now our middle term is just 1/4, and then that fraction divided by 4. So we've still got that double fraction, but it's a simpler version of the double fraction. Recall that dividing by something is the same as multiplying by its reciprocal. Again, we've got the fractions episode below if you need that. So instead of dividing by 4, we can multiply by 1/4, and that would get us 1 over 4 times 1 over 4, which is, of course, 1 over 16. That's also good news because we have a 16 in the denominator with the term to the right, which is 9 over 16. So now we've got 1/2 plus 1 over 16 minus 9 over 16. From there, we'll just want to create a common denominator by multiplying 1/2 by 8 over 8, which should get us 8 over 16. And then our total situation would be 8 over 16 plus 1 over 16 minus 9 over 16. If you combine that, the first two, 8 over 16 plus 1 over 16, you might notice that's 9 over 16, and then we have minus 9 over 16, which is 0. And that's our correct answer, which is option E, as in echo. Now, again, I would think that kind of thing would be mostly straightforward for folks like us as a group. Again, you might need to upskill or reskill with fractions if it's been a minute, like many of us had to. But outside of just being very early in your prep and needing to relearn and practice more with fractions, we've got 14% of people picking C, which is 15 over 16. So I just want you to think about for a second, like, why might so many of us, as an ambitious and intelligent and hardworking group of future business leaders, why might so many of us be going for C here? Think about that for a second. Recall that C is 15 over 16. The only way I was able to get 15 over 16 is by making a mistake in the middle term that we started with simplifying. So my guess is that most people get the numerator simplified correctly from 2/3 times 3/8. They get that down to 1 over 4 correctly, but then when they go to divide by 4, since it's 1/4 over 4, they mix up the reciprocal and they multiply by 4 over 1 instead of 1 over 4. So instead of having 1 over 4 times 1 over 4, which we did correctly a moment ago, they wind up with 1 over 4 times 4 over 1. They just like mix up that reciprocal in the denominator. And that would get you 4 over 4 as the middle term. Now, if we do the rest of the math right, you would have 1/2 plus 4 over 4 minus 9 over 16. If you make your common denominator 16, you would have 8 over 16 plus 16 over 16 minus 9 over 16. And if you work from left to right there, you would wind up with 24 over 16 minus 9 over 16, which then yields 15 over 16. And that would get us the incorrect option C. So what does that suggest about where people are going wrong here and us as a group in terms of like where we might be able to improve? I think double fractions, where you've got fractions in the numerator of another fraction, are inherently tricky for certain types of people. And I've definitely seen a lot of folks make mistakes with those kinds of double fractions. I've made plenty myself as well. And that can come from time pressure. It can come from not having good enough scrap paper techniques. It can come from having all of those things together, and then your brain just takes a vacation right at the moment where you need it the most. I mean, all of those things are totally common things, but perhaps obviously we don't want that to happen. So a good simple tactic that I've seen help people combat those kinds of mistakes is to actually always write denominators of fractions as fractions themselves right before you do the division of the numerator. So if you're going to do division by the denominator, And you're going to turn that into multiplying by the reciprocal instead of just doing regular division. If you're going to do that, then right before you do that, write the denominator as a fraction itself. So what I mean is, let's say you're going to do 1/4 divided by 4, like we're doing here. Instead of just going straight to, let me multiply by the reciprocal of the denominator and doing that in your head, make one additional step and write it as 1/4 divided by 4/1. I know that might sound like too simplistic, or maybe we're getting just comically into the weeds here. But again, think about what's at stake here with this test and your MBA and like what you stand to gain if things go well for you here. And then let's think about how a question like this could be 1 out of 21 questions. So that's a reasonable percentage of your entire quant score, which is, that's about 5% of your quant score. And then that's quant score is 30% of your overall score. So, this is quite a meaningful question. And maybe even more importantly, like if you know how to do the math, you deserve to get the question right. And so we just want to set ourselves up for success so that we're not missing questions because of something we're not writing down. You know what I mean? Like in some ways it pains me to like even make a recommendation that's that like detailed, but again, like I've just seen thousands of people miss questions like this, and yeah, I just don't think that's okay. Like especially if it's such a simple fix, you know what I mean? So anyway, sorry to like be so in the details with that, but I'm definitely coming from a good place, and like having made these mistakes myself back in the day, I struggled so much with this test. Now having watched just thousands of people struggle through the process as well, yeah, I've just come to really respect the fact that there's no small things. Like every single thing in terms of execution and making your execution as good as it can be totally matters. And it really adds up and compounds over time. So just giving you the advice that I wish someone had given me when I was starting out would have saved me a lot of time. So yeah, again, just if right before you do division by a denominator, just write it as 4/1 instead of just 4. Uh, and then turn that into the multiplication 1/4 times 1/4. I think it's just much, much more likely to get you to the correct path rather than what apparently happens for quite a few of us here. Because if you think about the thousands of people doing GMAT problems, 14% of 1,000, that's a meaningful group of people who are making that mistake. And again, could definitely see folks getting mixed up like that. But again, obviously we don't want that to happen to you when your MBA and like dream career is on the line. So small tip, but hopefully you didn't fall for that trap. If you did though, better to fall into that trap in practice than on an official exam. So if we're going to be wrong, let's be wrong in practice so we can learn and improve. If you're prone to making that kind of mistake, now you've hopefully got a simple, usable solution that's going to help. All right, so I recommend making any like desired notes to self there, something that you might want to remember for the future, or something that you think would be a beneficial takeaway for you. Either like email it or text it to yourself if you're on the go, or make a note in your like aggregate notes if you can, or make a flashcard. And let's move on to a question that you may find a bit more challenging. This is problem number 99. The problem says, on a scale that measures the intensity of a certain phenomenon, a reading of n+1 corresponds to an intensity that is 10 times the intensity corresponding to a reading of n meaning like the letter, they're using it as a variable. On that scale, the intensity corresponding to a reading of 8 is how many times as great as the intensity corresponding to a reading of 3? Let me read that again. On a scale that measures the intensity of a certain phenomenon, a reading of n+1 corresponds to an intensity that is 10 times the intensity corresponding to a reading of n. On that scale, the intensity corresponding to a reading of 8 is how many times as great as the intensity corresponding to a reading of 3? Option A is 5. Option B is 50. Option C is 10 to the power of 5. Option D is 5 to the power of 10. Option E is 8 to the power of 10 minus 3 to the power of 10. Again, I recommend pausing here, giving yourself some time to think through this one. It's definitely a more difficult question than the previous one by the numbers, with about 75% of us getting this one right. So it's not impossible, but clearly there are some big missing pieces for folks here, with a full 1/4 of all of us missing this question. So let's try to give you some tools you can use to make questions like this one easier. As with all quant problems, and word problems specifically, making sure you're clear on what's given and asked is super, super valuable. But it doesn't look like many people are misreading this question based on the wrong answer distribution, which I'll share a little bit later. Having said that, it does look like a lot of people have a difficult time understanding the concept behind the problem. And it looks like that leads down a few incorrect paths, which I thought was kind of interesting and like a potential good thing for us to dig into here. So I'm going to borrow a tip that I actually gave in our previous episode, which is to write out some half math, half English as a in-between step before trying to do anything too equation-like. And we're going to use that to help wrap our minds around exactly what the question here is telling me. So just to be clear, most people read a word problem like this and they immediately start trying to do math or go to an equation. And if that's working for you, please don't change. Like, I'm never going to argue with your results. But if you're struggling with that, then a good move is to go for an intermediate step between reading and getting to the math part, which is like half math, half English. I'll demonstrate that right now. So let's start by trying to understand this scale that they're telling us about. So we're told that a reading of n+1 corresponds to an intensity that is 10 times n. And anytime I have an equivalence like that, or some kind of sequence, I usually like to organize it with some simple rows and columns. And I think you might find that helpful as well. For example, here, I might write n+1 on the left, and maybe above that I would write something like reading, like the reading from the scale. And then I would make another column to the right of that and title it intensity. And then below that, I would put 10 times n. And that's just helping me visualize what the problem's telling me. From there, I've got a few options. I can try to go up that scale by adding a 1 to the reading. So like n+2 should equal 10 times n+1, which should give me an intensity of 100 times n. Now, if that makes sense, you can start to scale that up a bit and add a new line below the left column with n+3, and then to the right, that's 1,000 times n, because every time we add 1 to the reading, that should multiply the intensity by 10. If that's not clicking yet, or it's not seeming super approachable, that's okay. I'll give you an alternative that you can use in a moment. But for now, let's finish this way. We can then write that a reading of n+4 will be the same as an intensity of 10,000 n, and that a reading of n+5 will be the same as an intensity of 100,000 n. And of course, if we could keep going there, but that's not strictly necessary for now, because at this point, hopefully enough of the pattern is clear to be able to solve the question. So let's think about what the question asks. It's asking for the difference in intensity of a reading of 8 versus a reading of 3. Let's think about a reading of 3. If a reading of 3 plus 1 should be 10 times the intensity of a reading of 3, and 3 plus 2 should be 100 times the intensity of a reading of 3, and on and on and on with the same pattern we just mapped out, then we need to go from 3 to 8, and that's adding a 5 to the reading. So instead of just adding 1 5 times, we can just add a 5 to the reading. How many times are we going to multiply the intensity by 10 if we're adding 5 to the reading? Again, each time we add 1 to the reading, we multiply by the intensity of 10. So if we add 5 to the reading, we should be multiplying by the intensity, should be multiplying the intensity by 10 5 times. And that would get us to our correct answer of 10 to the 5th, which is option C, as in Charlie. So that's one way to approach that problem. Clearly, things are not that simple for a lot of people. So let's talk about how you could map this one out slightly differently, and just in case the above way of thinking about it isn't totally intuitive for you. Along with mapping things out as like half math, half English, which I basically did with my chart that I was just discussing, I didn't really have an equation. I was sort of just like writing out what happens each time I increase the reading and then like hoping I would see the pattern. Another way you can execute on that that could be easier for you, and the way different folks' minds work is to use numbers instead of variables like n. Sometimes just using numbers instead of variables is enough to get things to click a little bit easier. So you could do something like n equals 1, and then that corresponds to an intensity of 1. Like I'm basically just inserting 1 for both of those. And then I would map that out in the same type of columns organization I had before, with one column titled reading and the other titled intensity. Then for reading, instead of writing n plus 1, I'll just add 1 to the original number I put in to get 2. And then I would put 3, 4, 5, 6, 7 under that. And then on the right-hand side, it said I should be multiplying by 10 for the intensity. So that would be 10 times 1, or just 10. So at the top row, I'd have 1 and 1. And then in the next row down, I'd have 2 and 10. Because every time I add 1 to the reading, I multiply the intensity by 10. Some of you might just find it a little easier to wrap your mind around this if it's with numbers instead of variables. So then I can write a 3 under 2, meaning I added 1 again. And then to the right, I can multiply by 10 again and get 100. And then on and on and on. And a reading of 4 would be intensity of 1,000. A reading of 5 would be intensity of 10,000, that kind of thing. Again, sometimes just mapping out the pattern with actual numbers rather than with variables can help things click a little bit better. It's still the same two basic approaches I recommended earlier, though. I do want to put the attention on that for a second. You're not forcing yourself into an equation from the beginning. Instead, you're mapping out some half math, half English steps to help you understand the logic of the problem before you try to construct the mathematics of the problem. And then you're organizing the cases into two different columns. Those are the basic two approaches that I talked about before. And those are the same whether we're using variables or numbers. So highly recommend using those two ideas if they resonate. And then you can choose variables or numbers depending on what makes the most sense to you. And that should really help you get to the right answer on questions like this when there's some kind of interesting or unusual mathematical logic being presented here, like we have with this, what I believe is called the logarithmic scale. But most of us aren't thinking about that or wanting to think about that when we're taking the GMAT or when we're going to business school. So where are people going wrong here? And what can we learn from that? Well, we've got 12% of us picking B, which is 50. I think that's pretty understandable since that's close to multiplying by 10 5 times, but instead people are getting mixed up there and they're adding 10 5 times instead of multiplying by 10 5 times. And that's how you could get 50. So that could be folks misinterpreting the given information, which says n plus 1 corresponds to an intensity that is 10 times the intensity corresponding to a reading of n. They might be mixing that up. If you see 10 times something, that means you multiply by 10. If you see 10 more than something, that's when you add 10. So could be a vocab issue there, could just be an interpretation issue there. There could be a lot of things happening. But that's something that I thought was kind of interesting, and again, just goes back to there's no small things. Every single thing that we do, that we execute on, each process that we integrate into our approach, each time we condition ourselves to do the right thing, that's more likely to get us success versus less likely. It all compounds. So you may want a flashcard or a note to self on the terminology thing if you got mixed up with 10 times versus 10 more. But my guess is that's probably not the most common reason people pick B. I bet they're just getting confused by the logic and then picking something that makes sense to them without taking the time to map it out visually, like I recommended a moment ago. So that visual mapping with rows and columns, as simple as that is, should really make a positive difference for you if you're making mistakes like that. Another popular wrong answer is E as in echo. We got 7% of us picking that one, which is 10 to the 8th minus 10 to the 3rd. And that's definitely headed in the right direction, but my guess there is that people try to figure out the logic of the problem in their head, again, rather than mapping it out visually, just trying to shortcut it or kind of cut a corner there. But then they see E and they think oh yeah, that makes sense, multiplying by 10 8 times, and then I just subtract multiplying by 10 3 times. But if you map out the math there, you can see that that's not quite right. Either we've got a misinterpretation of how exponents work, that could be part of the problem, or we've just got people kind of, like I said, cutting that corner and just looking at E and thinking that makes sense. Multiply by 8 10 times, subtract 10, multiplying by 3 by 10 times, but that's just not mathematically accurate. So again, we've got to get the logic piece first, and then we can fit the math around that. And I think that's a big stumbling block a lot of us have for word problems because we're just so anxious to get the problem done. And that anxiety is like coming from a good intention of like wanting to do a good job and do it quickly and like get, good pacing going through the exam. But I truly think that's counterproductive. And I think you want to find productive ways to slow yourself down, not just telling yourself to slow down, which is hard to do, but developing habits that force you to go at the right pace, if that makes sense. Like if you're writing things down accurately and you're writing them down quickly, it's totally fine to go quick because like you still get the same benefit of decreasing your odds of making a mistake while not necessarily diminishing your speed too much. But it's probably slower than just doing it in your head. But there's just a risk reward trade off there that I would ask you to think about and really consider. Think about the big picture here and ask yourself like, is writing some stuff down on these questions worth decreasing my risk of not missing questions I know how to do? And I think it's like kind of obvious, I guess, to me, like when I think about that, but just asking you to do your own math on that. Don't want to like push my beliefs or approach on you too much, but do want to make some suggestions that again, I just wish someone had pushed me harder to do this stuff back in the day. I really could have used that like tough love, I guess. So as always, I recommend making a quick note to self on this one based on what you want to remember from that discussion, if there is anything that you want to remember, and then let's try one more problem together. This is problem number 104. The problem says Diana bought a stereo for $530, which was the retail price plus a 6% sales tax. How much money could she have saved if she had bought the stereo at the same retail price in a neighboring state where she would have paid a sales tax of 5%? Again, Diana bought a stereo for $530, which was the retail price plus a 6% sales tax. How much money could she have saved if she had bought the stereo at the same retail price in a neighboring state where she would have paid a sales tax of 5%? Option A is $1. Option B is $2.65. Option C, $4.30. Option D, $5. And option E, $5.30. Again, recommend pausing. Great problem to work on your algebraic translation skills here, especially with percent changes, both of which are super, super, super common on test day. So we've got a good number of us missing this one. Only 80% of us get this one right. So let's work on that. And again, let's just make this kind of situation easier for everybody. So much of what we discussed today and in recent episodes is going to apply here. So let's note what's given and asked. We'll set up some in-between notes to make sure we're setting up the math correctly and like getting that bridge of logic and math, especially since it looks like one wrong answer really dominates here. 14% of people are picking the same wrong answer here. And it's clear that it is just a misinterpretation of the logic of the question, much like the previous problem. I don't think it's a math mistake that people are making here. I think it's more of a logical mistake. So writing what's given, we know that she bought a stereo for $530. I might write something like stereo bought for $530 or original price bought equals $530 or something like that. The next part, though, is really, really important because it says that the $530 price includes the tax. So I'd probably write in parentheses includes tax, or I might write something like price plus tax equals $530. Like I would just write the left side of that equation as English. Again, just going for that like half math, half English step here. And that lets me know I'm not going to be computing 6% of 530 at any point in this problem. And we're going to come back to why that's so important in a moment. So we then get to the question, which is how much she would have saved if she bought the same product with only a 5% sales tax instead of 6. So I might write something like savings with a 5% tax rate equals question mark. Again, that kind of like half math, half English vibe. So I've got that set up and I can start to think about how I might put together some next steps. And here I can kind of take a step back and ask myself, do I want a more logical solution to a problem? Do I want to make an equation and have a more mathematical solution to the problem? All of those kinds of things can work. The point is just to make sure that you're clear on the logic of the problem before you proceed with trying to compute a bunch of stuff. So let's think about what we would need to answer the question real quick. I already know how much she paid with 6% sales tax. So I need to know how much she would have paid with the 5% sales tax. And then I'm going to be able to answer the question. But in order to figure out how much she would have paid with the 5% sales tax, I need to know the original item price before tax, because 5% of 530 is going to be totally wrong. That's just telling me the tax she would pay on a $530 item. But if 530 includes the 6% tax, then the original price before tax is lower than that. And if I knew that lower price, I could just do the 5% thing and then I would answer the question. So let's start by computing the original before tax price of the item. There are a lot of ways to do this, and we've touched on a few actually in this series. So I'll make a recommendation in a moment, but the key insight to have is we're calculating tax based on an unknown original amount. And the result of that percent increase is 530. That's the key insight. I know I'm like hammering that, but yeah, I just hate to see good people miss questions for bad reasons. Let's put it that way. So way too many people think we're taking 6% of 530, which is not what we're being told here. And you'll want to make sure you really think about that in all percent word problems going forward. So again, I'll give you some advice to make that easier. So yeah, why don't we just jump into that? So always ask yourself, is this a percent of a given number? And like a lot of times the problem will literally say percent of. And if it's percent of, you're going to multiply by a percent. But you also want to ask yourself, is the given number the result of a percent calculation on an unknown value? And that's really important because here 530 is the result. We increased an unknown value by 6% to get 530. So again, let's get into like how to make that easier, because I just think it's a sticking point for a lot of folks, and even just like talking through it like that, it's just not enough. So I could just make an equation, and that equation could say 106 over 100 times x, an unknown value, equals 530. I could do something like that. And there what I'm doing is I'm increasing the unknown value by 6%, and then I'm writing with an equation that's going to yield $530. And that's a great way to go if you're comfortable with that, by the way. Totally support that method. But I do want to share that I've found a lot of people are not super comfortable with that way of doing things, and they often make mistakes or they just get confused about how to set things up. So let's try to fix that. Anytime you're changing something by a percent, so it's not percent of, but it's like a percent increase or a percent decrease or a percent change or like a taxing something like we're doing here, which is almost always a percent increase, I highly recommend just always using the percent change formula. It's going to greatly simplify the amount of thinking that you have to do, and it generally leads to better results. Again, this will not be a fit for everybody, but if you're not having the success you want to see on these kinds of questions and you're not sure what to do about it, just always use the percent change formula when you're changing something by a percentage. If you don't recall the percent change formula, it's just new value minus old value, that difference divided by the old value, and then that whole fraction times 100. That equals percent change. So it's new minus old over old, that whole thing times 100 equals percent change. We've got a whole math basics episode on percents linked below if you want more help with that. But for now, I'll assume that the formula makes sense to you. And if you need to pause and hit that percents lesson, by all means, please do so. And we'll be right here when you're ready to continue. Let's talk about how to implement the percent change formula on this problem. So how do we know something's changing by a percent here? Well, any percent-based tax changes something by a percentage. So in general, tax calculations are percent change calculations. So that's how you could know that the percent change formula is going to help you here. So what's the new value? Well, that's the value after the percent change has been calculated. So in this situation, we know that's 530. What's the old value? That's the pre-tax price, and that's what we're trying to figure out here. So that's the left, I'm going to make a variable for that. So the left side of our percent change equation could look something like 530 minus x divided by x, and then that whole thing times 100. And then on the right side, that's the percent change, and we know that that's a 6% increase. So we would just write 6 to the right of the equation. Our full formula would be 530 minus x divided by x. So 530 minus x, that calculation, that whole thing divided by x, and then that fraction times 100, and then that equals 6. Now, that's a little bit more complicated than 106 over 100x equals 530. But again, If that simpler version makes sense to you, use it. If that's hard to generate, just use the percent change thing. A little complexity to make things easier to set up almost always pays off on GMAT quant questions. It's usually not crunching the numbers that bothers people. It's this logical piece. It's the organizational setup, getting things put in the right place properly piece. And that's why we're digging into that right now, because I think it's going to make a big positive difference for you. So since most of you who naturally go to 106 over 100x equals 530 won't have too much trouble solving that, let's go ahead and solve our percent change formula instead and just demonstrate what that might look like. So I'm going to divide both sides of the equation by 100 to start, which would give us 530 minus x over x equals 6 over 100. And then I'm going to multiply both sides by x to get rid of the denominator. If you're not super confident with your algebra skills, check out the Math Basics episode on equations. That's linked below for you, okay? So we're going to multiply both sides by x to get rid of the denominator. That's going to give us 530 minus x equals 6 over 100 times x. Then let's combine like terms by adding x to both sides. And that gives us 530 equals 6 over 100 times x plus x. Now from there, we just need a common denominator of 100. So let's write that, let's write the right side, as 6 over 100x plus 100 over 100x. And that's going to get us the equation 530 equals 106 over 100 times x. And that should sound familiar. And the point I'm making here is the percent change formula leads to the same result, but for many reasons is often easier for people to use and set up well. And so that's why I'm recommending it. It just takes the guesswork out of some of these percent change questions. It'll help make these kinds of problems easier for you if you struggle with them. If we go ahead and solve that equation, we would get that x equals 500. And that's really good news because we want to know the original price of the item before tax. And now we do. It was $500. And after we added the 6% tax, it becomes $530. Now we can use that to calculate how much we would have paid if there was a 5% tax, and then we can finish out our problem. So let's do that. Again, here's a situation where we want to change something by a percentage. So let's do that. The new value is unknown with the 5% increase. That's what we're trying to figure out. So the total price after the 5% tax, we don't know, but the old value we do know, that's the $500 pre-tax price that we just calculated, okay? So I'm just doing new minus old over old times 100 equals 5. And I'm just filling in the new minus old over old. So the left side of our percent change equation could be something like y for the new value, which is unknown, minus 500. That difference divided by 500, and then times that whole fraction times 100. And the right side is just 5 because it's a 5% change again. So our full equation, y minus 500 over 500 times 100 equals 5. Let's divide both sides by 100. That gets us y minus 500 over 500 equals 5 over 100. Then let's multiply both sides by 500 to get rid of the denominator. That's now going to get us y minus 500 on the left equals 500 over 100 times 500 over 1. And let's simplify the right-hand side by canceling some zeros. That'll get us 5 times 5, which is 25. Then we can add the 500 from the left-hand side to get y equals 25 plus 500, which means the price we would pay with a 5% tax is $525. So with a 6% tax, we paid $530. Now we know the difference that we would pay would be $5, which is our correct answer and option D, as in delta. So there are some tools that you can use to think through this one properly and avoid the significant pitfalls that we've got here. So let's discuss some of those. I really hope those help you because 14% of us are picking E, option E, which is $5.30. So really think about that for a moment. Any idea why so many folks pick E? The question asks us for the difference in price if we pay 6% versus 5% tax. So it looks like what people are thinking there is, oh, that's just a 1% difference. And then they're taking 1% of $530, which is $5.30. And if that is what's happening, that reflects an incorrect understanding of how percentages work, how taxes work, and how reducing taxes by 1% works. Because there what you're doing is you're multiplying by the post-tax value instead of multiplying by the pre-tax value, which is what we want to do. We definitely don't want to be thinking incorrectly about percentages or percent changes or how taxes work on the GMAT, let alone in business at large. So what I've done here is try to give you some tools to keep you from making a logical mistake. 1% of 530 is not right because, again, 530 is the after-tax amount, and percentage changes are not based on that. If you execute well with those kinds of tools, you should see success with these types of problems going forward. And if you ended up picking that answer today, that's totally fine. Like, who cares if you're getting it right in practice? All that matters is you get it right on test day. Okay, so just use it as an investment in your future success. Hopefully, I also gave you some tools to help with the math setup mistakes. The percent change formula is going to keep you from inverting percentages or putting the wrong percentages in the wrong place, which can lead to some of the other incorrect options that are less popular, but nonetheless, like, equally painful, I think, when you look at the answer and realize that you missed something like this. So again, if you execute well, you should see success. And that's good news because percent word problems are some of the most common questions on the quant section on test day. In fact, they are currently the most common question that I see in the quant section. So, as always, please let us know if you have thoughts, feedback, or questions about anything that we have discussed here today. You can reach us at the GMAT Strategy on current social channels if you want to DM, or you can email us. Our email address is contact@thegmatstrategy.com. We will be back soon with some more helpful advice to get you your dream score faster. In the meantime, if you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies. Talk to you all soon.